Hey, Andy.
Hey, Ryan.
How's it going?
It's going great.
You're here to give me a home energy audit.
That's what I'm here for.
What does that mean? What's it all about? What are you planning on doing?
Well, we're going to find out where your house is using and losing energy. We're going to look at your appliances, your mechanicals, your insulation, your windows, everything like that. And we find out where you're losing the energy in your house. Why do you want an energy audit?
When I think about my house, I want to save energy because I'm an environmental scientist, but I also want to save money because that makes sense.
Right. That's important. A lot of people are interested in saving the environment and reducing their carbon footprint. A lot of people are obviously interested in saving money, and a lot of people are interested in increasing the comfort of their homes.
Cool. Will you show me around?
Yeah.
Nice. Where do we start?
Take me to your basement.
Start from the bottom, move up.
Start from the bottom and move up.
All right. We've got the furnace and the water heater.
Yep, there they are.
You're saying that these are really important energy hogs to think about?
Well, these are the things that use probably the most natural gas in your house. So these are the things that you're most concerned about as far as how efficient they are, whether they're working properly.
Technology is changing, so it's making it more efficient.
Much more efficient. We can go from, this is about an 80% efficient furnace to maybe 95 or 96% efficient furnace. So you save 15% on your energy bills right off the bat.
Wow. Can we look inside?
Absolutely. Let's do it. So as you can see right now, we've got a flame in there. This gas flame in there. That's heating up the heat coils and transferring the heat from the flame into the air that's blowing through the house. So that's how they work in a nutshell. A closed combustion furnace, you wouldn't be able to see those things, and you wouldn't have the potential of carbon monoxide getting into your house, which is another reason that you might want to consider a closed combustion high efficiency furnace. 100% of the heat, of the energy that's delivered to your house in the form of gas is turned into heat when it's here. Some of it's lost through the flue, so in this case it's only 80% efficient, but electric heat, although it turns 100% of the electricity into heat, a lot of it's lost on the way to your house. So maybe 70% is lost in what's called line losses on the way to your house. So it's burning coal far away or natural gas far away and creating energy, but that energy is lost on the way to your house.
Wow. Can you tell me a little bit about the water heater?
Yeah. Well, this is just a standard storage tank water heater. It works sort of like a pot on a stove in that you've got a bunch of water in here. The gas down here creates a flame which heats the water. The flue gases go up through the middle of the tank and transfers some more heat into the water, and then it goes up through this flue and out of the house. In this type of standby storage tank, it's probably 55 to 60% efficient typically, so it's not very efficient.
Are there other options?
Yeah, a real popular option lately is the tankless water heater. The tankless water heater is just what it sounds like. There's no tank like this one has. A lot of the losses in a tank water heater are because you're losing energy through the tank itself.
How efficient?
Anywhere from about 80% to 90% efficient.
Right on. Let's keep going.
Right.
We've come upstairs, but we're looking at a simple little plug. What's going on?
Well, we're trying to check the insulation in your walls, and since you don't have any holes in your walls except for where plugs and outlets and switches are, we're going to check the insulation through this wall plug. So I'm going to go through the edge of the electrical box. I'm going to try to hook some insulation in there and pull it out, and I can see that you do have insulation, so that's a good thing.
Right.
I can tell what kind of insulation is fiberglass bat, and I know that because it's a 2x4 wall, it's probably R11 or R13, which means the wall cavity is full of insulation, so there's not a whole lot more you can do to add insulation.
I usually think of windows as the major problem of a house, whether they're going to leak or not, and heat could escape. Tell me about mine.
Well, you've got vinyl windows, they're double pane windows, so just off the top, I think they're probably pretty good. I have a little device here that's a low E detector that detects whether there's a low E or low emissivity coating. And if it has that, it means it's a little more efficient than a typical double pane window. In this case, you do have low E windows. Yeah. So I think your windows are okay. A lot of people have single pane windows. That's where we really start to talk about whether it would make sense to replace them. But most people that have modern double pane windows, the best investment's usually not going to be in their windows, it's going to be somewhere else in their house.
How about leaks around the outside?
That is an issue. A lot of times there's cracks around the outside of the window where the caulking is. We're going to test for leakage in a few minutes when we use the blower door.
Blower door.
The blower door.
Let's do it.
Let's do it. So before we do the blower door test, we want to make sure that all the windows and doors are tight. So I'm going to make sure that these windows are sealed up so we can find leaks that are elsewhere, find leaks in the house that aren't the windows.
Makes sense.
So we're using what's called a calibrated fan hooked up to a manometer that's going to determine exactly how much air is going through that fan. And based on the volume and the size of the house, we can then figure out how much air is going through the fan and therefore how leaky your house is. All right. So we're going to turn the fan on. We're going to get the house to a pressure of negative 50 pascals. That's the standard pressure for measuring leakage in a house. So right now your house is losing through that fan about 2008, around 2,000 cubic feet per minute through the fan.
You're now going to take this and put this through your computations and figure out what's going on.
Exactly.
Cool technology.
This is the infrared camera. We're going to find where the leaks are. Right now, you know, we can see we've got some leaks happening around the top of the door up there, so I'm going to take a picture of that. Outlets are usually pretty bad, unless you've got a gasket around them or a caulk around them. In this case, there's quite a bit of cool air coming through that outlet. If you put your hand over it, you can probably feel it.
Oh my gosh, you can feel the wind coming through.
Right. So I see you've got a charger plugged in. It's not actually plugged into anything, but it's actually using electricity. As you can see, it's actually pretty hot.
This is warm. Yeah, it is warm.
It is. According to this thing, it's 101 degrees on there. The wall around it's 72 degrees. So even though nothing is actually drawing energy from the plug, the transformer itself is using energy.
I have so many things plugged in right now, and I've never really thought of them as drawing energy. If they're not being used, no energy. But this is telling us differently.
Right. Most of today's electronics are drawing energy. The flat screen TV, the DVD player, the cable box are all using energy 24 hours a day, whether they're actually looking at them or using them or not.
So a safe thing for me to do would be to unplug anything that I'm not using.
Right. 8-foot ceilings in most of the place.
So take me through what you're doing now.
Well, I've calculated the size of your house. I've measured all the ceilings and all the vaults, and I know the volume of the house. I'm putting all that into the computer so I can figure out the leakage rate. I can do it by hand, but I cheat and I use the computer because it's a lot faster.
Sure.
So I figured out that your house is losing about 37% of its air every hour. The natural air changes, as we call it, 0.37. So every 3 hours, you're replacing all the air in the house with new air.
That's a lot of air that I'm losing.
It is a lot of air, but on the other side, the flip side of that is you've got to have a certain amount of air coming into the house. You have to have fresh air coming into the house. So if we tighten your house a whole lot more, you're going to want to think about mechanical ventilation.
Because there could be toxins that build up in the house.
Exactly. Your house is okay in this regard, but around this area, the number one thing that most people can do to improve the efficiency of their house is to add insulation to the attic or to their ceilings. Heat rises, so if you don't have enough insulation up there, you're going to be losing heat all year round.
We were downstairs looking at expensive things like the furnace and the hot water tank. What are your suggestions on that one?
In the case of your furnace, it's about 20 years old. You probably have another 3, 4, 5 years left on it, so it's time to start budgeting for a new high-efficiency furnace. It would make sense to replace it with a new furnace that's high efficiency, but you don't want to replace it until you have to. The same goes for the water heater. Unless you wanted to have an impact on the environment, and that's what's most important to you, financially it doesn't usually make sense to replace the water heater with, say, a tankless water heater until that one fails, and then it makes sense to replace it with a more efficient unit. The same would go for any appliance in your house. If you replace an inefficient refrigerator with a very efficient refrigerator or a more efficient refrigerator, then the difference in energy usage will pay off for itself very quickly.
What are 5 simple things that I can do to reduce my energy costs of this house?
Well, this house in particular, you can air seal, you can seal up some of the cracks, you can put gaskets behind the light switches and the outlets, some foam gaskets that are about 10, 15 cents each. You might consider putting some pipe wrap. This stuff is about $1 for a 3-foot length around the water heater pipes where they come out of the top of the water heater. That'll save the energy from bleeding off of the pipe, so it doesn't have to work as hard. Obviously, the thing that a lot of people are doing now is compact fluorescence. You can get these for less than $1 each. They saved 75% of the energy compared to an incandescent and put out a very similar type of light. So CFLs are the #1 thing you can do, the quickest thing you can do. And even an energy efficient shower head. This looks like any other shower head that you might have in your shower. The difference is this one puts out 1.5 gallons a minute versus 2.2 gallons a minute.
You've brought up just a couple other things like turning off the lights, but also unplugging any appliances that I might have that aren't in use, but they're still taking up energy. We saw that in the thermal imaging.
Right. The thermal camera showed that you had something plugged in that was actually hot. It was 100 degrees. That's energy being used. It's being wasted for something it's not actually being used at the moment.
I'm an environmental type of guy. I thought that when you were going to come in here, I was going to come flying out with shining colors. Everything would be fine.
There's a lot of stuff that most people can do. I've been in very few houses doing an audit where I've walked out saying, you know what, there's nothing else you can do. An auditor is trained to look for those little things and help somebody figure out what are the things that you can do.
Wow, thank you so much for your time.
Well, thanks for letting me in.